Hi everyone, my name is Lei and my advisor is Stephanie Valencia, and our project is AI Enhanced Communication Support System for people with aphasia.
It's okay.
It's okay. I know.
What's it like to live with aphasia? How would you describe it?
It's just incredibly sad to know that I can't be as smart as I used to be.
This is a short video to introduce the people with aphasia. So, aphasia is an acquired communication disability. It will impact the processing of language, including your comprehension and your production. It's most often caused by the brain injury from a stroke, but it's not only challenge the ability to express yourself, it also challenge your daily lives and your social interactions. So the research for aphasia will involve a lot of disciplines, including computer science, psychology, speech-language pathology, and of course, human-computer interaction. So before AI, there are some traditional communication ways for people to express themselves. So maybe some of you know this man is in the Breaking Bad. He used some very traditional ways like facial expressions and the signals, the bell, and the communication board. He will point to the alphabet on the communication board. And there are also some electronic devices for them to use. This is an example. They will choose the pictures or the alphabet or the words on the screen to generate the speech, have the voice output. And why we choose the large language model here to aid the people with aphasia? From functional perspective, it will understand the user's inputs in the natural language and whether they typed or the spoken, and it can predict the user's intention and offer autocomplete options. And from the personalized support the perspective, it can learn a user's habits and their preference, and it will provide dynamic interaction via text, voice, and video. So our research goal is to explore AI-enhanced communication technologies that can benefit people with aphasia. Based on our research goal, we will conduct 3 phases of research. The first phase is the semi-structured interview. We will gather their requirements because we want to solve the problem. What are the design needs for people with aphasia's rehabilitation and communication? And the second phase is the storyboarding. We will visualize our design ideas and validate requirements we gathered from the first phase because we want to solve the problem. How can AI support their communication and rehabilitation needs? And the third phase is the user testability. We will develop and evaluate the system because we want to know what are the experience when using such AI-enhanced communication system. So we are currently in the first phase, and we have conducted some interviews with people with aphasia. And we will have 3 parts of questions to do interviews. The first is general questions for the aphasia experience, because when talking about their personal experience, they can use their best language. So we will use their best language to analyze their speaking patterns and the current barriers when communicating. So we will ask a question like, what's the most frustrating experience after your aphasia? And second part of the question, we will explore the concrete needs for the language support because we want to explore the specific strategies to support the communication. So we will ask a question like, what's your barrier when you trying to speaking for a complete sentence? And the third part of the question is the ideation to inform the potential future technology. We'll ask them to imagine the future use of large language model. And this is one storyboard example to explain the definition of AI. This is a scaffold. And we will ask the question like, what are the features you would like to see in the AI tools in the future? So this is our project, and thank you very much.
Hi everyone, my name is Selma. Today I'll be presenting my research titled Talisman, an approach for inclusive co-design with personal objects as design materials. This was conducted alongside my two dissertation co-advisors, Dr. Beth Bonsignore and Dr. Joelle Chan. Whether tangible or intangible, objects are an important way that people can enact aspects of their identities and lived experiences. However, a commonly overlooked problem in participatory design and co-design in general is that material objects are often imposed on users. Facilitators typically ascribe objects like colored pencils and microcontrollers without knowledge of whether these objects are relevant or useful to users' situated contexts or goals. For example, in their work with lower-income African-American older adults, Harrington et al. Found that the adults felt belittled and skeptical when using ideation materials like colored pencils and markers. And Giglito et al. Found that members of a Borg Arab Egyptian Bedouin community were less open to experiment with things that might make them look incompetent, such as colored cards. We propose an approach that shifts control of design materials to users by inviting them to bring in personal objects from their lives. Using research through design, we developed a socio-technical system called Talisman, consisting of a flexible set of techniques to scaffold user selection and interaction with their personal objects in the design process. This includes a customizable prompt to support participants' material selection, set of discussion-based design activities called the 4Cs, as well as a tablet and Padlet to support distributed participatory design, and an open source toolkit for communities to use on their own. We're excited to share the first demo of the Talisman toolkit at the end of this presentation. We evaluated Talisman in a series of case study deployments over the course of a year. We collaborated with 3 different communities in US urban cities focused on STEM education for young adults ages 16 to 22. The 3 communities were focused on safe spaces, environmental justice, and programming education, respectively. We worked alongside community champions who had an established relationship to faculty at the iSchool to embed Talisman in co-design workshops alongside the young adults. We directly observed how the community champions and young adults took up Talisman in the design of solutions for their communities. For the sake of time, I'll give a short overview of the findings from the first workshop conducted alongside a STEM education nonprofit based in Chicago, focused on creating youth-led safe spaces. The workshop participants were young adults selected as community ambassadors. In the workshop, they focused on designing a spring kickback event for their peers. Using the Talisman prompt, the facilitator invited the young adults to bring in something from their lives that represented safety or made them feel safe. The young adults went around in a circle sharing the objects they brought in while the facilitator wrote them down. The young adults then drew connections between the objects and brainstormed key considerations when designing a safe space. Lastly, the young adults came up with themes and activities for their spring kickback event inspired by their previous discussions. Overall, we found that users brought in pieces of themselves that served as sources of inspiration, motivation, and shared understanding. Across all 3 case studies, we observed the tangible impact Talisman and the personal objects had on young adult participants. For example, Daiki appreciated the fact that he had a choice. Farida also appreciated the fact that she was able to see the emotional connection that her peers had to their objects and the profound impact that the environmental issues can have on individuals and communities. And Bedri appreciated how personal each of his peers' objects were and his ability to see where they were all coming from. Through a cross-case analysis of the 3 case studies in which Talisman was deployed, we found that Talisman helped seed decision-making power over material selection from facilitators to users, support users to share what they wanted in the format they wanted, and led to productive outcomes across a breadth of design topics, modalities, and ways of deploying. Overall, this research suggests that Talisman may be an adaptable approach to scaffolding selection and use of personal objects in co-design. expanding the ways that users may enact aspects of their identities and lived experience in broader participatory and asset-based design practice. Lastly, we're inviting you to test our toolkit and take it up in your own design practice. You can find it at www.talismantoolkit.com. Here is a quick walkthrough of the Talisman toolkit. So when you open up the website, you'll see an overview of the approach. You'll also see an overview of the suite of techniques and some other resources. You'll see a sample use and accompanying video, and also a contact form for you to contact the team should you have any questions, any feedback, or should you choose to have used the approach. We would love to know. So thank you so much for attending my HCIL Symposium talk, and I look forward to hearing from you.
Good morning, everyone. My name is Noel Kyriakos, and I'll be talking about my experience with journey maps for a project that I'm working on right now. In 2022, Maryland introduced public pre-K for the first time in the state, and there's a lot of research showing that early interventions such as pre-K can lead to sustained learning outcomes in K through 12 and beyond. For example, pre-K teachers use literacy intervention to develop language literacy for pre-K. My area of research is introducing computational literacy to pre-K students. And my conjecture is that by introducing that early, you can probably have better chance of having adoption of students towards computation, especially for historically marginalized and minoritized communities who traditionally don't go into the different areas of computation. So we have to start with teachers, right, to introduce this in pre-K. So how do you introduce a new content area like computational literacy to pre-K teachers, and then how do you actually deliver an effective PD for them, because 80% of PD professional development in teaching is not very effective or efficient. So we interviewed 14 public pre-K teachers. We conducted interviews with them, and we wanted to understand what they're thinking, what their emotions are, what their hopes are in terms of PD, and really to understand what they want in terms of a PD that will introduce computational literacy for them. We used design-based approaches, and we used a lot of data-driven methods to surface problems, issues, and challenges that they had, and then we refined them into user stories and use agile development methods to iterate on them to get into some sort of like steady state. And then we actually used learning engineering and service design to design our options and solution space. So journey maps is an artifact that you can use to develop your solutions. For example, you can take the user stories and put them into a two-dimensional space. On the x-axis, you can put the user stories and the thoughts and goals, observations of the participants into stages. So it's a chronological layout of their stories. And on the other axis, you can put down their emotions, touch points, and the interaction spaces. Basically to understand what the participants are thinking about and how they will, how they perceive the problem. And it allows you to visualize, right? Makes thinking visible so that the participants and the designers can have one common source of truth. So you can use a journey map for the experience design to explore the solution space. You can incorporate the trade-offs and constraints that are involved in your design in the design context. For example, in professional development in the state of Maryland, there's certain regulations in terms of how you deliver it and what is included, so you have to consider that. And it allows you to generate these options, and it can allow you to rank those options. And we can use those same user stories and the story map and use a Kano model to figure out which features bring delight, which is the top half of the quadrant, which are the must-haves, which is the bottom half of the diagram towards the right side, my right side. And it allows you to kind of look at priorities and at least arrive at some sort of semblance of a possible solution or a solution set. So some of the things that, again, this is an ongoing project. Some of the things that that we found so far, for example, using journey maps as a design artifact, is to pre-K teachers are very busy. They have very stressful lives, right? You've heard teachers also. All teachers have stressful lives, but pre-K teachers, especially, I think, have stressful lives. So they want flexibility in terms of their learning, professional development. So we found that asynchronous modalities is something that they really desired. But unfortunately, because the state of Maryland has certain regulations, all of it can't be asynchronous. Some of it has to be synchronous. So we came up with this 80-20 split to deliver a course. So for example, one continuing professional development credit involves 15 hours. So you can think about 80% of the 15 hours will be delivered asynchronously. The other fact that surfaced is, and we're thinking about pursuing this even further, is using podcasts for the initial transfer learning. Podcasts have low cognitive load versus having participants read, right, materials. And it's very flexible. They can multitask while they're listening to podcasts. Just curious, how many of you actually listen to podcasts? Yeah, I've met more and more people where they are listening to podcasts more to receive information than actually reading about it, at least for the initial phase of it. And you can use transcripts of the podcast if you want to go back and review things. You can slow down. There's all sorts of benefits from it. And we also found that teachers want micro credentials, meaning they want to earn to learn. So instead of waiting 15 hours to get the credit, it motivated them to learn and continue things by using micro credentials. So I'll wrap up really quickly here. So Journey Map makes thinking visible, right? It makes mindsets visible. You can use it as a continuous scorecard, not just for incremental development, for foundational development. And we're thinking about using like large language models and a chat interface to actually help the participants surface their mindsets, what they're thinking, and their feelings. Thank you very much.
Thank you, Noam. I'd like to invite Zayu up, who's going to be presenting the next two talks.
Hello. Cool. All right. Hi, folks. I'm Zayu from UMDCS, and then I'm working with Huaishu Peng. And so our lab is kind of probably situating in a slightly different space than probably the most of you. We're on the hardware side of HCI, like the technology side of HCI. So we try to develop hardware prototyping methods to support different communities. And this project specifically, we focused on printed circuit board prototyping. So this project is about making circuit board without soldering, but with a 3D printed housing. The main reason we care about PCB is that one, PCB is mostly like necessary for any interactive smart electronic devices, like your phone, your watch, and everybody is really making PCB designs and prototypes who are making these devices. And two is because the current prototyping process of the device, of the PCB, is creating a lot of e-waste during the process, especially these small electronic devices that are hard to desolder and deassemble for reuse after the prototype is done with this lifespan, even though they're still functional, right? So in this project, we propose a solderless PCB assembly method. So we attach these components with a 3D printed housing to the PCB so that they are easily detachable for reuse in the future. And here is a quick illustration of how we want to implement this. All right, so the main idea is just to press down the components to the circuit board with a 3D printed housing. And here is real-life example. So you can 3D print the housing, put the components in, and bolt it onto a circuit board with bolts and nuts. And then this is basically your PCB. It's functional. And the one that is showing is a NFC business card, and I actually have 2 duplicates of this that you can pass around and try on your phone if you have an NFC sensor. I promise there's only just a project webpage. There's no virus or anything. So if you have an iPhone, the NFC tag is going to be on the top of your phone. And then if you have an Android, it's usually at the back, somewhere in the middle. And on the card, there's an NFC icon. Basically, just tap that on your phone. Yeah, so but the point of this project is not to make a business card, right? Like the point is that if I don't want that business card anymore later, then I can always disassemble it and then reuse the components in there for future like projects, right? So on a higher level, I want to highlight 2 use case scenarios of solderless PCB. One is that we can harvest components from old prototypes and use it for future projects, or just restock it for future uses. And secondly, there are a lot of projects which will go through multiple iterations in the circuit board design, and then a lot of times the components are shared like in a large portion between each iterations, so we can reuse the functional components between each iterations. And yeah, so basically we actually did a lot of like evaluations about like the PCB performance and the durability, but then in general, this is the idea of solderless PCB. And we're aware that the components are not the sole stream of waste generated through the PCB prototyping, and we're looking at different options to help with the rest of those waste streams in the future work, so stay tuned. And as Jessica mentioned, this is a paper that we just presented at Kai a couple weeks ago, and here's a QR code. I think that leads to the same link of the link in the business card. You can check out our full paper for details. And just one more highlight, we developed around 140 versions of 20 different prototypes in this project during development. And then in the traditional way of prototyping, these will take about 1,000 electronic components, and we're actually using only 200 components in the developing process, and also all 200 of them are still functional. We can also restock them for reuse. So hopefully this will make an impact if we make a deployment later. Yeah, so that's all about solderless PCB. So yeah, obviously sustainability is not the only focus of our lab, and then we develop like digital fabrication methods to help with democratization of functional prototyping as well. So this is an archetype of 3D printing magnetophoretic displays. Basically, the displays is going to be low power, so they're going to be always on without any power. It's kind of like a 3D printed version of an Etch-a-Sketch, like the toy, but then in a 3D surface, so they can be more organic. So apparently, there are existing commercial low power displays like e-inks, LCDs, electrochromic, and magnetic Etch-a-Sketch displays, but then they usually come in rectangle shapes. So in this project, we want to explore ways to combine the low power drawing display with 3D printing, so we can make 3D objects with customizable textures. And this will give like designers more options after the thing is being made. And we call it 3D printed magnetophoretic display. And the principle is pretty simple. If you consider this is 1 pixel, like in the 3D, and the black particles are magnetic element. So the black particle is magnetic element, and the white are passive element that's not reacted to magnet. So when magnet is present at one side of the display, the black powder will get attracted to the magnet side and then push the white element to the other side. So basically the display will display a dark color on one side, and then if the magnets move to the other side, it will just move vice versa. So the pixel will display white color. And in practice, these are the mixtures, the materials. The black powder are just iron powders, and then the rest of the mixture is the mixture of mineral oil, baby powder, and foot dye. And the reason why this is complex is because we have to make sure that each cell is reactive to the magnet in the right like time and response. Like basically, if you put the magnet, it has to be in the right viscosity and etc. to make sure that it responds to the magnet right. So this is the mixture, and to inject the mixture into the cells that during 3D printing, we modified a 3D printer with a mixture injector. So what happens is that we will start with the regular printing and leave the cells with the top open. And the injector will go at the right location and then deposit the mixture into the cells. And then the 3D print will resume and cover up the cells so that layer by layer, this whole 3D print will be embedded with cells with the mixtures. And we also develop a software design tool for anyone who wants to try this. So you can basically import any mesh that you download from the internet, and the software will basically calculate where the cells should be put at, and then automatically tessellate the surface with some customizability of the size and shapes of the cells. And so basically this will be a Stanford Bunny model processed by the software. And we also have a custom slicer so that you can directly just process the 3D model for 3D printing, and after printing you can just draw on your bunny. And we also did a bunch of experiment on like the cell sizes and the mixture liquid and stuff. And then these are some more examples that we printed. And then we also tried to automatically activate some of the stuff with slightly irregular shapes so we can use motor to control the movement of a magnet. But yeah, so this is some preliminary exploration towards the vision of the ultimate display, where displays can be everywhere and can do everything. But yeah, I guess we are still far from it, but then we hope that this could be a first step of democratizing like low power display manufacturing using like a hobby 3D printer. So the above is 3D printing magnetophoretic display. And thanks for listening.
Thank you.